Welcome to the second video in which I take a look at Graham Hancock's claims regarding the Piri Reis map to see if they hold any water. So if you haven't seen the first video, this map is called the Piri Reis map. It was drawn in 1513 by an Ottoman man named Piri Reis, and it used to be a world map, but only this piece of the Atlantic survives. And Graham Hancock has claimed that this map shows evidence of the existence of an ancient global seafaring civilization with advanced technology comparable or possibly greater than what we have today that existed during the last ice age. This is not a theory he came up with himself. This is called the Hapgood hypothesis and was developed back in the 1950s. So why does Hancock believe this map shows evidence of this ancient civilization? Well, he points to four main features of this map that he says demonstrate this. The first one we covered in the last video, so if you haven't seen it, I invite you to check that out. And this claim involves the provenance of the map, or the map sources used by Piri Reis. So Piri Reis gave us some information in his map. You can see there's a lot of text on the map here, and some of this text is him telling us how he put this map together, what source maps he used, and Hancock has claimed that in that text, Piri Reis tells us he used some very ancient source maps that must have contained information dating from the last ice age. So if you'd like to know how well this claim stood up against scrutiny, you can check out this video. Spoiler alert, things didn't go well for Hancock. You might say he completely lied about what the map says. But don't take my word for it, you can go check out this video. Essentially, all I did was compare what's written on the map with what Hancock claims is written on the map. The second thing he points to involves the accuracy of the map. So he claims that this map is far too accurate, and in particular the longitude and latitude, but mainly the longitude, is far too accurate for the technology at the time when the map was made in the 1500s. Therefore, he claims, Piri Reis must have had some source maps made by some civilization that had technology to map longitude especially accurately. And this must be this civilization from the last ice age. That's what we're going to be investigating in this video. The third claim he makes is that this landmass down here is Antarctica as it was during the last ice age, and that we'll be looking at in the next video. The fourth claim he makes, which I'll also have a separate video for, is that this island here is the Bahamas, or the Grand Bahama Banks, as it was during the last ice age. Let me preface that I'm not an archaeologist or a historian or a cartographer, so if I say anything that's egregiously wrong, especially if it pertains to the argument, let me know in the comments. Essentially, all I'm going to do in this video is compare what's on the map with what Piri Reis or what Graham Hancock claims is on the map. And if I need any further information not directly available on this map, I'm going to be taking that from this book called The Piri Reis Map of 1513 by Gregory Mackintosh. This book examines in detail every single corner of this map, every place name, every text on the map, and goes over every theory that has been put forth regarding this map, including the Hapgood hypothesis, which he devotes an entire chapter to. So without further ado, let's take a look at the claims regarding the accuracy of this map, and if they hold any water. Now, in order to claim a map is accurate, you need to know something about how the map was made, because there are a number of ways you can map a globe onto a flat piece of paper, and many of them look drastically different from one another. And actually, Hancock has a theory on this, so I don't want to misrepresent him. So we're going to watch a clip and let him tell you in his own words.
One of the most famous of these maps is the Piri Reis map. And I'm showing it here because I want to compare the projection of this map with the projection here, centered on Cairo. Notice the west coast of Africa and the east coast of South America. And coming down here to the Antarctic Peninsula, tonguing up towards the south of South America. It's that precise projection that we find on this 1513 map. Again, there's the west coast of Africa, the east coast of South America. And coming down here, we find a representation of the northern Antarctic Peninsula.
Okay, so I found the map he's referring to. It's this one right here. And just so you can be sure that this is the same map, let me pull it up on the video. And he's claiming this is the precise projection, his words, the precise projection used by Piri Reis in making his map. But he doesn't actually demonstrate this. He just pulled up one map and then pulled up another and pointed out that they look rather similar. I mean, at first glance, that's true. They do look kind of similar, but does that mean it's the same projection? I mean, can you really just make this claim by eyeballing it? Well, I went ahead and overlaid these maps. I chose to overlay to get Africa accurate because that's the closest part to the center of the map. That's the part that's going to be the least distorted. And when you do that, you find that Europe is pretty far off, and South America, or the Americas in general, are way off. I mean, this doesn't match at all. This is astounding that Hancock would claim this. So it seems like Hancock here is just banking on the fact that quick visual inspection is good enough for evidence. Now you might say, okay, they don't match, but maybe Piri Reis got his math wrong and he was attempting to do a similar thing. Unfortunately, there's a problem with that. You see, this map is called an azimuthal equidistant projection. You've probably seen such a map before, just not centered on Cairo. You've probably seen this map. This is azimuthal equidistant projection, but this one is centered on the North Pole. So you're probably familiar with this map. It's used in the UN's logo, the United Nations, and it's also used by flat earthers to claim the Earth is flat. We don't actually know what projection scheme he used, but we do know that this is what's called a Portolan map. And I discussed this in the previous video. Portolan charts are maps that were made in the early Renaissance, late Middle Ages, and they're navigational charts, and what they show are rhumb lines. That's what these red and black lines emanating from these compass roses are. They're lines of constant bearing. That's what a rhumb line is. It's also called a loxodrome. They tell a sailor which bearing they must take to go from one place to another. Your bearing is the angle at which you're traveling relative to north. So if you're traveling due north, that's a bearing of 0 degrees. And if you're traveling east or west, that's a bearing of 90 degrees. And the important thing here is that these rhumb lines are depicted as straight lines. And that is proof that this cannot be the projection scheme used by Piri Reis or any projection remotely similar to this, because rhumb lines will not show up as straight lines on this map. And in fact, I can prove that. If we zoom in, we see the longitude and latitude lines. Those are themselves rhumb lines. One is a rhumb line of 0 degrees, the other one is 90 degrees. And you can clearly see that they are curved. They're not straight. So this claim by Hancock is just categorically false. In fact, it's rather shocking he would try to equate these two maps. It either means that he's done zero research on map projections or the Piri Reis map, or what Portolan charts are, or he's done the research and knows perfectly well that comparing these two or equating these two maps is mathematically impossible, but he's presenting it that way anyways because it kind of suits his theory, banking on the fact that, well, what percentage of his audience is actually going to know anything about cartography and map projections or the Piri Reis map or what a Portolan chart is or what rhumb lines are? I mean, most people are just going to follow his lecture and glance at the two maps and say, yeah, that's true, they do look kind of similar, and be satisfied with that. So already we've caught Hancock in a major lie. Now, this doesn't mean that the map itself is highly inaccurate. Maybe it is still accurate and too accurate for the 1500s. We still have to check that out, but we have to figure out what projection scheme Piri Reis might have used. And there in fact is a projection scheme that does have this property of straight rhumb lines, and that's the Mercator projection. You're probably familiar with the projection too. It has a notable feature, which is that land masses near the poles are grossly enlarged. And the other feature it has that is probably less known is that rhumb lines appear as straight lines. In fact, that's why it was developed as a navigational tool. So, did Piri Reis use this projection scheme? Well, officially, the Mercator projection was not developed till some 50 or 100 years after the Piri Reis map was made, at least in Europe. So it is possible that the mathematics for this map was known maybe to the Turks, and we just don't have a historical record of it, but probably he did not use this projection scheme. He might have used a similar one. Probably what he used, I would guess, is this projection scheme called the equirectangular projection, because this one was developed by the Greeks, so he would have known about it. In fact, he says in his map that he used a lot of charts from the Greeks. Or the Greco-Romans, I should say. Now, this map looks very similar to the Mercator projection, but it is a little different, and rhumb lines don't appear as straight lines on this map. Although, if you have a small patch of the Earth, then rhumb lines will be very close to straight lines, approximately straight, as long as you're not too close to the poles. For example, if you're just mapping the Mediterranean, which is where Portolan charts were first developed, you could get away there with using this projection and representing your rhumb lines as straight lines. The deviation wouldn't be too large. But over a world map, you're going to have problems. So now that we have an idea of the projection scheme that he likely used, we can now get into this claim of looking at the accuracy of longitude and latitude. And again, I don't want to misrepresent Hancock's claims, so we're going to watch a couple clips and let him explain his longitude and latitude arguments for himself. While you're watching these clips, this would be a good time to take a moment and like and subscribe if you haven't already.
This is one of a whole category of maps which are extremely hard to explain. All of them based on older source maps, now lost. All of them incorporating extremely precise relative longitudes and latitudes. Latitude is not that difficult a technological feat, but longitude is a difficult technological feat. Longitude involves a chronometer. It involves knowing the time at the place you began your voyage and the local noon as well, and calculating the difference between them. You need a chronometer that will keep accurate time at sea with the motions of a ship. And it's just a plain fact that our civilization did not invent such a chronometer until the late 18th century. Before that, we didn't know what longitude we were at, and ships were constantly sailing unexpectedly into coastlines that they thought were hundreds of miles further away.
All right, so he doesn't say specifically in this clip that he's talking about the Piri Reis map, but he is. You can watch the full podcast. This is on Joe Rogan to see. And in fact, I use clips from this same podcast in the previous video. And the argument here he's making is that we couldn't calculate longitude at the time this map was made, at least not accurately or not even remotely accurately. And that's true. But this is true for the navigator in open seas, who has no other bearings or references than the sky, and who has to figure out his longitude right now and his latitude. Piri Reis is not a sailor in open seas. He's a cartographer on land, so he actually has other tools available to him that are not available to the seafaring or the guy in open seas. And we'll discuss that in a little bit. Now, I want to also point out that he does say that latitude is extremely accurate, although that's a rather easy one to get. And that's also true. To get your latitude, all you have to do is measure the altitude, an angle above the horizon of the noontime sun, or you can do the same thing with the North Star. Assuming you're in the northern hemisphere, you can do a similar thing in the southern hemisphere, although there is no southern star. Now, he continues with his argument, so we're going to watch another clip. This clip immediately follows the one we just watched, and let's just see what he has to say here.
The discovery of the technique to do longitude was a major civilizational advance. Its presence in maps based on much older source maps that actually show the world as it looks during the last ice age suggests that somebody during the last ice age was mapping the world and had mastered the technique of calculating longitude.
Okay, so here we get to the crux of the argument. He combines the fact that the Piri Reis map has highly accurate longitude as well as the fact that it depicts the world as it was in the last ice age, that this must mean that Piri Reis used some older source maps that had information dating back to this advanced civilization that could map longitude accurately and must have been around during the last ice age. So regarding the accuracy of the map, there are two claims we have to check here. One is that the map actually is extremely accurate, because if it's not, then none of this holds any water. The other claim is that whatever the accuracy of the map is, it could not have been achieved given the technology in the 1500s. So, first thing we're going to look at is just how accurate is this map? Now, we've found more or less the type of projection he must have used, and the main claim is that longitude and latitude are extremely accurate. Well, this is actually a problem, because if you take a look at the Piri Reis map, you'll notice that there are no lines of longitude and latitude on this map. So, how do you know if they're accurate or not? We have no clue what longitude and latitudes Piri Reis thinks these land masses are at. So again, it would seem that Hancock is just eyeballing this. He's taking a map and saying, well, they look pretty similar. And remember, he's comparing to this projection, which we found is way off. But even if he's comparing to a more reasonable projection, yeah, you can recognize what's going on. They do look similar, except the parts where they don't. So again, we're running to this problem of Hancock is just eyeballing things and thinking that that's good enough research. Now, I said that there's no longitude or latitude on this map, but that might not be strictly true. I discussed this in the previous video, and it does appear that there might be 3 latitude lines and possibly one sort of longitude line. So the latitude lines, it would appear that this compass rose here is centered on the Tropic of Cancer. So if we go back to the world map, the Tropic of Cancer is here. And so relative to Africa, this is pretty much dead on with the Tropic of Cancer. Relative to the Americas, well, we don't know because this part of the Americas is clearly not accurate. This here can be identified as the coast of Colombia, and that should be running east-west, not north-south. So that's way off. And the reason that's way off is he had a map from Columbus, he tells us. He must have tried to match other maps to Columbus, so he had to turn this on his side. This island, though, is identified on the map as Puerto Rico. So he's got the Tropic of Cancer going through Puerto Rico, which is not correct. If we zoom in, Puerto Rico is here and the Tropic of Cancer is above it. In fact, the Tropic of Cancer goes through the Bahamas, which he says is this island here. So already, based on his own theory, the latitude is off, which remember is the easy one to get. Already that seems to be a problem regarding the accuracy of this map, requiring some advanced technology. This compass rose here appears to be centered on the equator. If we zoom back out here, we can see where the equator is, and at least relative to Africa, it's pretty much dead on. But relative to the Americas, it's pretty close. It's a little bit high or a little bit too far north. If we take a look at where the equator cuts through Brazil, it pretty much cuts right through where the Amazon empties out into the Atlantic, which would be right here. So it's a little bit high, but not too bad. And it's possible that this compass rose, in the book, he argues that this might be centered on the Tropic of Capricorn, but it's actually too high relative to both Africa and Brazil. More so with Brazil. It's more off with Brazil than with Africa. And in fact, I'm not convinced that this is centered on the Tropic of Capricorn, because if you look at the vertical distance between the equator and this compass rose, it's smaller than between the equator and this one here, which is on the Tropic of Cancer. And they should be equal. Now, what about longitude? There are no longitude lines on here, but there is a text right here that gives reference to a longitude line. So let's take a look and read what it says. And I'm going to take this translation from Wikipedia. The translation itself is not from Wikipedia. It's from a guy named Axura, and that translation is also referenced in the book. Here's the text, and it says, "The Portuguese infidels do not go west of here. All that side belongs entirely to Spain. They have made an agreement that a line drawn 2,000 miles to the western side of the Strait of Gibraltar should be taken as a boundary. This is 2,000 Turkish miles. The Portuguese do not cross that side, but the Hind side, Hind is India, and the southern side belong to the Portuguese." Now, this text is referencing the Treaty of Tordesillas. This is a treaty between the Spanish and the Portuguese that all land found west of this line will belong, all new lands discovered will belong to Spain, and any land found east of it will belong to Portugal. The line is this solid line here. Ignore this dotted line, that's a different line. And if we zoom in, we can see where that cuts through Brazil. Now, the problem is this treaty did not define the line as a longitude. The way it worded it was some distance west in leagues of the Cape Verde Islands. And the problem is the definition of a league is ambiguous. There's Spanish leagues and there's Portuguese leagues, and they're not exactly the same. And even then, there are multiple definitions of the league for the Spanish, and there's multiple definitions of the Portuguese league, although all of them kind of hover around 5 or 6 kilometers. So you can get a rough idea that this line should have sat somewhere around 46 degrees west of Greenwich. And if you compare where that is to the Piri Reis map, if you just drop a straight line down from this text, it actually cuts through pretty much exactly the right spot. So that does give us at least one possible longitude line, along with the 2 other latitude lines. If in fact this is a 3rd latitude line, it's wrong. It's not in the right place. So if the latitude has problems, and it does, we saw up here, as well as possibly here, how can you claim you need an advanced technology because the latitude's the easiest one to get? Now, some people have tried overlaying a map onto the Piri Reis map, a modern map onto the Piri Reis map. And so here's one you might have found online, and it looks pretty accurate. The old world and the new world seem to match pretty well. There are some inaccuracies. Of course, again, we're running to this problem where it's accurate except where it isn't. You know, here is way off and this is not accurate. You can't just look at the accurate parts and ignore the inaccurate parts and then claim your map is accurate. But either way, this black projection cannot be the projection used by Piri Reis because rhumb lines will not show up as straight lines on this black map. Another overlay of maps you might have seen is this one. So this comes from a website by this guy here, Diego Cuoghi, and discusses the Piri Reis map. He actually argues against Hancock's claims, but it seems like he's done his best to overlay Brazil, at least. And it looks like it matches pretty well. I think by looking at this, looked at this for a while, I'm pretty sure this red map is a Mercator map. But it doesn't really matter because this is close to the equator. So the Mercator map and the equirectangular map will be the same or very close to the same near the equator. And so here you might say, well, wow, this does match really well. Yeah, it matches well only in South America. We don't know what the rest of the map looks like. So I went ahead and overlaid the Piri Reis map onto a Mercator map and tried to match as best I could what this guy did on his website. And when you do that, the rest of the map is way off. I mean, Africa is off by hundreds of miles, at least, if not 1,000 miles. And look at where Spain is. It's way off. I mean, this is probably over 2,000 miles off. So that's definitely not accurate. But if you take a look at where the Tropic of Cancer is, the two maps don't line up. They've got the equator lined up, but the Tropic of Cancer doesn't line up. So this is probably not, from a historical point of view, the way you should be overlaying these maps. What you should probably do is try to match up the two latitudes and the one longitude that we have found, and then see how accurate it is. So I did that as well. So here you can see that I have overlaid the Tropic of Cancer on top of the Tropic of Cancer. So I've lined them up. Same thing with the equator. And I tried to line this up with this latitude that separates Spanish and Portuguese territories. And when you do that, well, we find that actually Africa matches up really nicely. And, you know, South America is pretty good, but it's still off. I mean, this is easily hundreds of miles of a discrepancy, which is totally doable in the 1500s. I mean, error of hundreds of miles is exactly what Hancock quoted in the clip we watched. So I don't see what the problem is here. Yeah, it's very accurate, but it's not too accurate for the times, even according to Hancock's own example. And again, Spain, it's much better than before, but you're still off by at least a few hundred miles, if not 1,000 miles here. I mean, it's pretty good. Okay, I don't want to take anything away from Piri Reis. This is, given the times, this is a pretty damn good map. Remember, this map was made in 1513. That's like 20 years or so after Columbus discovered the New World. So to get such a good map in 20 years is impressive. But to claim that it's beyond the technology of the times, I'm not buying it. And if that wasn't enough, there are other problems with the longitude. For example, take a look at where the Andes are. The Andes are sitting right here. They should be off the map here. That would be the correct placement. I mean, he's got the Andes going straight through the Amazon, like in Brazil, in the middle of Brazil. So that's way off. So again, tons of things are way off. So this claim of accuracy, I'm not totally buying it. The question is it too accurate for the times? Now, Hancock has argued that they didn't have a marine chronometer, so they couldn't get longitude accurately at all. And that's true, but as I said earlier, that's true for the guy at sea. The guy at sea has no bearings. All he can look at is the sky as a reference point. So he's got this major issue. And the way they did it back then was they used something called dead reckoning, where you try to estimate the direction you're going and how fast you're going, and then try to figure out where you are based on that. But you're at the mercy of wind and water currents there, and they were way off all the time. So this was a major issue. And it wasn't solved until the invention of the marine chronometer. However, if you can see land, you can triangulate your position with reference points on land every so often and figure out your longitude and latitude fairly accurately. We do know, it's a historical fact, that the Portuguese mapped the coast of Brazil and Africa that way. So getting an accurate coastline is not a problem, whether it be Africa or Brazil. The problem is locating South America relative to Africa, because there's no point between them where you can see both coasts simultaneously. But actually, this can be done without a marine chronometer. The marine chronometer is for the guy at sea, in open seas. He needs to figure out his latitude right now. And he needs to do so using very primitive tools, like this one. And he's on a wobbly ship that's bobbing up with the waves, so it's very difficult to get accurate measurements. But the cartographer doesn't have to do this. For one, he can use measurements that were taken on land. If you're on land, you can get much more stable and accurate measurements. And he's in an office piecing together information from old maps and various different expeditions and the navigational logs from these expeditions. And if he's a competent cartographer, he can meticulously take out his straight edge and compass and piece together where the ship was and make a coastline that way. So getting accurate coastlines is not a problem. The difficult part is placing the relative positions of the two continents. But this can be done using astronomical observations that have different timings in different locations. For example, he can use timing of an eclipse. So someone, say in Brazil, can observe an eclipse, write down his observations, and then wait around a year or two before sailing back to, say, Portugal and compare his results or his data to some astronomer in Portugal who observed the same eclipse. And if they are competent astronomers who took good measurements and have good mathematical skills, they can figure out their relative positions, their relative longitudes and latitudes. In fact, Columbus did that when he went to the Americas. He did it twice. He did it once by observing an eclipse from the island of Hispaniola and once from Jamaica. Now, it turns out he was way off by like 15 to 30 degrees in longitude, probably because he wasn't that great of an astronomer, or he might have fudged the numbers to convince people he had landed in Asia. All this to say, there are tools available to the cartographer for figuring out longitude that are not available to the sailor in open seas. The sailor in open seas cannot observe an eclipse and then telephone back to someone in Lisbon or wherever to see what they observed and then compare the two to figure out longitude. So in conclusion, Hancock's claim that you couldn't figure out longitude in the 1500s is true only for the sailor in open seas. For sailors who could see land, there are other methods available, triangulation, and there are even more methods available for the cartographer, and so mapping longitude accurately actually is possible in the 1500s, as long as you are a competent cartographer. And Piri Reis was a competent cartographer. We know this because we actually have an entire book of maps by Piri Reis called Kitab-i-Bahriye. We can take a look at some of these maps, and we can see that not only is he a good cartographer, but he's quite the artist. And I mean, most of these maps involve small islands and things like that, but he does have a couple large-scale maps. For example, he's got this map of Europe, which is quite well done. I mean, this guy clearly is good at his job, and you immediately notice that this is Europe and Northern Africa. I mean, is Hancock going to claim that this map and all the other maps in this book were made using information from this ancient civilization? I mean, there's other maps on here that are quite accurate. This is the Black Sea. You can immediately recognize it. Very well done. And actually, he has 2 world maps as well. It's quite well done. This one actually does have longitude and latitude lines on it. It also has what appears to be Antarctica, although it's enormous. And if we zoom in, we can see that the Caribbean now looks much more like it was supposed to. So looks like he's figured out that Columbus was wrong and he's decided not to reuse his map. He's got another world map here. And this time he doesn't have Antarctica. So did he leave it out? Why did he leave it out? I don't know. And again, the Caribbean looks much more like it's supposed to look like. So clearly, Piri Reis is a very competent cartographer, so I don't see why he could not have made this map. That book, by the way, was made some 15 years after this map. So in conclusion, let me know what you think in the comments. In my opinion, I don't think there's evidence that this map is too accurate for the times, or that it's not possible to accurately map longitude based on the absence of a marine chronometer. That argument only holds for the guy trying to figure out his position right now in open seas. In the next video, we're going to take a look at the claim that this is Antarctica and that it's Antarctica during the last ice age. If you made it this far, you'll probably enjoy the next video, so please be sure to like and subscribe if you haven't already, and hit the bell to be notified for when that video is released.